talked about the standard model of particle physics, for example, including, remember, all the particles, the leptons, the quarks, and the bosons, and also the force carriers. So remember that the bosons were the force carriers. And class, what were the fundamental forces of nature? Everybody? So the fundamental forces of nature are, tell me. Eversore. Hi, Free Energy Mobile. How are you doing? Gravitation is one of them. And next. Electromagnetic force is one of them. Strong nuclear force and weak nuclear force. Come on, guys. We've talked about this so many times. So many times. What are the fundamental forces of nature? Gravitation, electromagnetic force, strong nuclear force, and weak nuclear force. Those are the four fundamental forces. The non-gravitational ones are unified at certain extreme energy regimes. Remember this discussion? Gravitation is not unified with those three. And this is the issue. Okay, we will keep going. The three forces it incorporates are all described by quantum theories. The fourth of the fundamental interactions is gravity. So, quantum mechanics does a good job of incorporating electromagnetism, strong nuclear force, and weak nuclear force. Of course, strong and weak nuclear force, these are being discovered well into quantum mechanics and particle physics being a thing. At this point, of course, the standard model is not going is going to do a good job of explaining these things, right? So electromagnetism, those are carried by the force carrier of photons. Photons carry electromagnetism. Electromagnetism, light, remember? Light's particle nature is photons, so photons carry electromagnetism. Strong nuclear force. What? Everybody, listen with your ears cleared. Listen with your ears cleared. Nobody is saying anything correct right now. Listen with your ears cleared. Strong nuclear force is carried by what? Gluons. Weak nuclear force is carried by the W and Z bosons. We've talked about all of this. We've talked about all of this in particle physics class. We've talked about all of this. Everything's made of light. No! Everything is not made of light. No! Okay, so remember class, the non-gravitational forces, electromagnetism, strong nuclear force, and weak nuclear force, these three are unified in particle physics, quantum mechanics. Quantum mechanics has an explanation for this. But what about gravitation? Is there a particle or a particle physics-y or a quantum mechanics explanation of gravitation? No, indeed there is not, and that's an issue. Okay? This is where we fall short in quantum mechanics. So, it is ironic that it is general relativity which really began the modern era of theoretical physics that should provide the stumbling block to further progress toward a unified theory of all the forces of nature. Why? Because general relativity is the theory for gravitation. Gravitation is not explained by particle physics. It's not explained by quantum mechanics. See how that's an issue? Because there's the four fundamental forces of nature. Three of them are unified.